Welcome back, my dear students. In the last session, we have finished part 1 of chapter number 11, Mensuration. Today, let us learn part 2 of chapter number 11.
Some important formulas. Now let's learn some important formulas. Formula number 1, area of a trapezium. Here this figure is trapezium. In this trapezium, this side and this side, these two sides are parallel, and the length of this side is A and the length of this side is B, and the distance between these two parallel sides is heights. So now area of a trapezium formula is height. Here this height is this heights into sum of the parallel side means A and B are parallel sides divided by 2. Now height becomes this heights, and sum of parallel side is A plus B divided by 2, and this is the formula to find out area of a trapezium. Now formula number 2, area of a quadrilateral. Quadrilateral is a plane closed figure which is bounded by 3 line segments. So this is a quadrilateral, and here AC is a diagonal, so that is represented by D, and this is perpendicular line, and this is represented by heights 1, and this is also perpendicular line, and this is represented by heights 2. So area of a quadrilateral is half this D is diagonal, and these are height 1 plus height 2, and this is the formula to find out area of a quadrilateral, where this diagonal and height 1 and height 2 are two altitudes. This line and this line, these two lines are called altitudes. Now formula number 3. Area of a rhombus. In a rhombus, all the 4 sides are equal in length. So this side and this side and this side and this side are equal in length, and this is also diagonal and this also diagonal. This diagonal is represented by D1, diagonal 1, and this diagonal is represented by D2, diagonal 2. So area of a rhombus formula is half diagonal 1 into diagonal 2, where D1 and D2 are the two diagonals of the rhombus. So for this rhombus, D1 and D2 are the two diagonals. Now if we learn this formula these 3 formulas, now let's try exercise 11.2. Let's study the question. Exercise 11.2, question number 1. The shape of the top surface of a table is a trapezium. Here this is the shape of a table, and this shape is a trapezium. Find its area. We have to find out area of this trapezium. If its parallel sides are 1 meter and 1.2 meter, here this side and this side are parallel side, and the length of the parallel side are, this is 1 meter and this length is 1.2 meter, and perpendicular distance between them is 0.8 meter. So this parallel side and this parallel side in between, from here up to that, is the distance between the parallel sides, and that is 0.8 meter. Okay, now let's try to solve this question. So question number 1, solution. We know area of a trapezium is equal to, the formula to find out area of a trapezium is height into sum of parallel side divided by 2. Therefore area of this table is equal to height. Here distance between these two parallel side is 0.8 meter, so there is height. So 0.8 meter into sum of the parallel sides. Here 1 meter and 1.2 meter are the parallel sides. So 1 meter plus 1.2 meter and divided by 2. Then next step is 0.8 meter into, let's add together 1 meter plus 1.2 meter. 1 plus 1 is 2, so we will get 2.2 meter divided by 2. If these 2 divide this 2.2, we are getting 1.1 is equal to 0.8 meter into, this is 1.1 and meter. Let us multiply these two. 8 one time is 8 and 8 one time is 8. Meter into meter is meter square. after point here is one place, after point here is one place, altogether two place. So 1, 2, so decimal point will come here, and first you write 0.88 meters square here. This is the area of the table. See, yarni ko, gyan tarni ko. And to the next question to see. Question number 2 is same, so you try this question number 2. Now let's try question number 3. Length of the fence of a trapezium shape fill ABCD, this ABCD is 120 meter. If BC is equal to 48 meter, CD is equal to 17 meter, and AD is equal to 40 meter, find the area of this fill. Side AB is perpendicular to the parallel side AD and BC. So question number 3, solution. We know length of the fence of trapezium is equal to perimeter, and length of the fence of trapezium is AB plus BC here, BC plus CD here, and AD. So AB plus BC plus CD plus AD are the length of the fence of trapezium, and perimeter is given in the question, that is 120 meter. So perimeter is 120 meter. Now AB is to find out AB plus BC is given 48 meter, and CD is given 17 meter, and AD is also given 40 meter. Now next steps. So next is AB. Let's write this AB here. Then plus sign. 48 plus 17 plus 40 is 105 meter, and this is equal to this 120 meter. Next is AB is equal to, if this plus 105, if we are transposing to the other side, plus sign will be changed to minus. So 120 meter minus 105 meter. Therefore AB is equal to, from this 120, if we subtract this 105, then we are getting 15 meter. So the length of AB is 15 meter. So now we are getting AB is equal to 15 meter. So this AB length is 15 meter. 15 meter. Next is, therefore area of the trapezium is equal to, this is the formula to find out area of a trapezium. Height into sum of parallel side divided by 2 is equal to, here in this figure AB is the height, and that is 15 meter. So height is AB, that is 15 meter, into sum of parallel side is 40 meter plus 48 meter, and this will be divided by 2. Here height is 15 meter, sum of parallel side is 40 plus 48 and divided by 2. Now next steps. So 15 meter into 40 plus 48 is 88 meter, divided by 2. 2 divide 88, that is getting 44. Now 15 into 44. So 15 into 44, 4 5 times is 24, times 4 5 6 60. Again 4 into 5 is 20, to carry 4 times 5 6. If we add together, we are getting 660. So we are getting 660 meter into meter is meter square, and this is the answer. See, bab tarni ko. Next, let's try this question number 4. Let's study the question. The diagonal of a quadrilateral shape fill is 24 meter, and the perpendicular drop on it from the remaining opposite vertices are 8 meter and 13 meter. Find the area of the fill. So this is the diagram, and this is the diagonal. Length is 24 meter. From here up to there is 24 meter, and to this diagonal the perpendicular drop are 13 meter, and this also perpendicular 8 meter. Now we have to find out area of the fill. So this is a quadrilateral, and we have to use the formula to find out area of a quadrilateral. So area of a quadrilateral is half into diagonal into height 1 plus height 2, and this height 1 and height 2 are 13 meter and 8 meter. So half is here, and here diagonal is 24 meter. So 24 meter into height 1 is 13 meter, and this height 2 is 8 meter. These two can divide 24, then we are getting 12. So 12 meter into 13 plus 18, 8, 9, 10, 11, 21 is getting 21 meter. Now let us multiply these two. So 21 into 12. 2 1 time is 2, 2 2 are 4, 1 1 time is 1, 1 2 time is 2, then this is 2, add together 4 plus 1 is 5, then 2. 252 is getting. 252 meter into meter is meter square, and this is the answer. See, gyan tarani ko yare ko. Next, let's try question number 5. The diagonals of a rhombus are 7.5 centimeter and 12 centimeter. Find its area. Now let's try this question. In this question, it is given that diagonals are 7.5 centimeter and 12 centimeter. So this is diagonal 1 and this is diagonal 2. So solution here, diagonal 1 D1 is 7.5 centimeter and diagonal 2 is 12 centimeter. We know the formula to find out area of a rhombus is half diagonal 1 into diagonal 2. So half first. Diagonal is D1 is 7.5 centimeter. D2 is 12 centimeter. 12 is divided by 2. 2 6 times is 12. Now 6 will multiply this. 6 5 times is 30. 3 carry. 6 7 times 42, 43, 44, 45. So 45.0 is getting centimeter into centimeter is centimeter square. And 0.0 have no value, so we can leave 0.0. So we are getting 45 centimeter square, and this is the answer. See, yarani ko bhatare ko. Question number 6 is same, so you try this question number 6. Now let's try this question number 7. Let's study the question. The floor of a building consists of 3000 tiles which are rhombus shape, and each of its diagonals are 45 centimeter and 30 centimeter in length. Find the total cost of polishing the floor if the cost per meter square is ₹4. Here it is given that the tile is in the shape of rhombus and the diagonals are 45 centimeter and 30 centimeter. So 45 is diagonal 1 and 30 centimeter is diagonal 2. Now solution. For rhombus shaped tiles, diagonal 1 is 45 centimeter and this is diagonal 2, D2, 30 centimeter. Then we have to use the formula to find out area of a rhombus. So the formula to find out area of a rhombus is half diagonal 1 into diagonal 2. So therefore area of each tile that is rhombus shape is equal to half D1 into D2. Half D1 is 45 centimeter and D2 is 30 centimeter. So 2 can divide 30, then we are getting 15. Now let's multiply 45 into 15. 45 will multiply by 15. 5 are 25. 5 4 times is 20, 21, 22. 1 times 5 is 5. 1 4 times is 4. 5 7 6. We are getting 675. So 675 centimeter to centimeter is centimeter square. Next is total number of tiles that is given in the question. That is 3000. So total number of tiles is 3000. Therefore area of the floor will be number of tiles into area of a tile. That means this. 675 centimeter square. Now let us multiply this 3000 into this. 3 5 times is 15, 1 carry. 3 7 times is 21, 22, 2 carry. 3 6 times is 18, 19, 20. Then 1, 2, 3, number of 0 is 3 centimeter square. Now this centimeter square, let us convert into meter. In 1 meter square, there are 100 into 100 centimeter square. So to convert this centimeter square into meter, we need to multiply, we need to divide this by 100 into 100. So 2025000 will be divided by 100 into 100. 100 into 100. Now we are converting into meter square. This 0 and this 0 are cancelled, this 0 and this 0 are cancelled, and this 0 and this 0 are cancelled. If 10 divide this, we will get 202.5. If 10 divide means 1 decimal place, meter square. And this is area of the floor. Next is, hence the cost of polishing the floor is, in the question it is given that the cost of polishing per meter square is rupees 4. So this rupees 4 will multiply area of the floor, that means this. So rupees 4 into this, 202.5. Now let's multiply this. 4 5 times is 20, 2 carry. 4 2 times is 9, 10. 4 2 times is 8. Here 1 decimal place. So point will come here, and this is rupees. So this 0.0 have no value, so leave 0.0, then we are getting rupees 810, and this is the answer. See, yari ko gyan tari ko. Question number 8 and 9 you try. Now let's try this question number 10. There is a pentagonal shaped park. This is the pentagonal shaped park as shown in this figure. For finding its area, Jyoti and Kavita divide it into two different ways. This is diagram of Jyoti and this is the diagram of Kavita. Find area of this park using both ways. This way and this way we have to use, and we have to find the area of this park. Can you suggest some other way of finding its area? Now we have to find out other ways to find out the area of this park. So this is the question, and this is diagram, and this is Jyoti's diagram, and this is Kavita's diagram. Now let us solve. Solution. Jyoti's diagram. That means this diagram. In this diagram, area of one trapezium, here two trapezium are there. This is first trapezium and this is the second trapezium. Now for this one trapezium, if we want to find out its area, then according to the formula to find out area of a trapezium, height into sum of parallel sides divided by 2. So next step is, here height is from here up to there. There is 15 by 2. 15 by 2 meter into sum of parallel side is this side and this side are parallel. So parallel side are 15 meter and 30 meter, and we have to add together 15 meter and 30 meter. 15 meter plus 30, this 30 meter. And this will be divided by 2. Next is 15 by 2 meter into, let us add together 15 and 30. 15 plus 30 is 45. 45 meter divided by 2. Now let us multiply 45 into 15. 5 5 are 25. 5 4 times is 20, 21, 22. 1 5 times is 5, 1 4 times is 4. Now let's add together. 576. We are getting 675. So 675. 2 into 2 is 4. Meter into meter is meter square. We are getting this. Now therefore area of the pentagonal shape. So here there are two trapezium. Here one trapezium, here another trapezium, and these two trapezium will be equal in area. So since there is two trapezium, so 2 will multiply this area of one trapezium. That means this 675 meters square divided by 4. 2 can divide this 4. 2 times is 4. Now 675, let's divide by 2. 2 3 times is 6. Again 2 3 times is 6. Next is 15. 2 7 times is 14. Next is 10. Point now. 2 5 times is 10 meter square. This is the area of the pentagonal shape. Now Capita's diagram, let's take this. So Capita's diagram, area of the square. Here this is a square shape. This is 15, this is 15, this is 15, and this also will be 15. And we know that area of a square is side into side. So area of the square is side into side. So here the side is 15 meter and this also 15 meter. So 15 into 15. 15 meter into 15 meter. 15 into 15 is 225. Meter into meter is meter square. Next is area of the triangle. Area of the triangle. And this is the triangle. And we know that the formula to find out area of a triangle is half base into altitude. Here, this side is base. And this side is altitude. From here up to there is length is 15 meter. And this altitude also 15 meter. So half base is 15 meter and altitude height is also 15 meter. Now 15 into 15 is 225. Meter into meter is meter square. Now this 225, let us divide by 2. 2 1 time is 2, 2 1 time is 2, 2 2 time is 4. Next is 10, 2 5 time is 10 meter square. This is getting. Therefore, area of the pentagonal shape is equal to, here area of the square is this. So we have to write down this. 225 meters square. Then area of the triangle we have to add this. 112.5 meters square. Now let's add together. 225 plus 112.5. 5 plus 2 is 7. 2 plus 1 is 3. 2 plus 1 is 3. We are getting 337.5. 337.5 meter square. This is the area of the pentagonal shape. Now we have to try this. Can you suggest some other way of finding its area? Now we are going to find out there is any other way to find its area. Okay, now let's try. So this is the given pentagonal shape. From here up to there is 15 meter. From here up to there also 15 meter. From here up to there is 15 meter. From here up to there is 30 meter. Now let us produce these sides like this, and let us produce this side. And here one triangle is forming. Here also another triangle is forming. Now let's find out from here up to there this length is how much. To find out from here up to there this length, from here up to there this length will be 30 minus 15. 30 meter minus 15 meter, and this is 15 meter. From here up to there is 15 meter, and next is from here up to there this length is 15 meter. So here from here up to there this length also will be 15 meter. 15 meter, and this point will be the center of this 15 meter. So from here up to that, this length will be 15 by 2 meter. From here up to there also, this length will be 15 by 2 meter. Now first of all, let's take this triangle and let's find out area of this triangle. We know that area of a triangle is half base into altitude. Another way of finding its area. First, let's find out area of this triangle. Area of one triangle. And in the bracket, shaded portion. And the formula to find out area of a triangle is half base into altitude. So half, here base is this 15 by 2 meter, and this height is from here up to that. That is 15. So 15 meter. 2 times 2 is 4. 15 into 15 is 225 meter into meter is meter square. Now 225, let's divide by 4. 225 divided by 4. 4 5 times is 20. 2 and 5. 4 6 times is 24. 1, next is 0. Here is point, so put point. 4 2 times is 8. Next is 2. Put one more 0. 4 5 times is 20. So we are getting this. 56.25 meter square. There are two triangles, this triangle and this triangle. Therefore, area of the two triangles so here the area of these two triangles will be equal. So 2 will multiply this 56.25 meter square. 2 5 times is 10. 2 times 2 is 4 5. Point. 2 6 times is 12. 2 5 times is 10 11. We are getting this 112.50 meter square. And this 0 let's leave. 112.5 meter square. Here, this whole figure, we see that this is a rectangle. And from here up to that is 30 meter. And from here up to that is 15 meter. And we know that the formula to find out area of a rectangle is length into breadth. So if we want to find out the area of this rectangle, we have to multiply 15 meter into 30 meter. Now let's find out area of this rectangle. Area of the rectangle, let's name this as A, B, C, D. Area of the rectangle A, B, C, D. We know that the formula to find out area of a rectangle is length into breadth. Length into breadth. So length is 15 meter and here breadth is 30 meter. Let's multiply this. 15, if we multiply by 30, we are getting 1450. So 1450 meter square. Therefore, area of the pentagonal shape. So if we want to find out area of this pentagonal shape, then from this whole rectangle we are going to subtract area of these two triangles. So area of the rectangle ABCD is this 450 meter square. Then area of the two triangle is 112.5 minus 112.5 meter square. So from this 450, let's subtract 112.5. So here let's put a decimal point and 0. 10 minus 5 is 5, then 10 minus 3 is 7, then 5 minus 2 is 3, then 3. We are getting this 337.5 meter square, and this is the area of the pentagonal shape. Here it is over. See, yani ko bab tare ko. Next question number 11 is same, so you try this question. Now exercise 11.2 is over. Now let us learn about solid shapes. So solid shapes. This figure I have drawn is cuboid. In cuboid, from here up to there is length, from here up to there is breadth, and from here up to there is height. And this point is called vertex, and this face is called face, and this line is called edge. Now this is cylinder. This figure is called cylinder. Here this portion is curved face, and this is plane face, and this is a circle, and this figure is called cone, and this face is called base, and this is a circle, and this portion is curved face. And here this is cube. In cube, length, breadth, height are equal in length, and this solid figure is called pyramid. Now let us learn this formula. The first one is cuboid. From here up to there is length, from here up to there is breadth, and this side is height. Formula number 1, total surface area of a cuboid. You see, this is a cuboid. Here there are altogether 6 faces are there. This face and this face and this face and this face. That means 4 faces. 1, 2, 3, 4. Then this 5 and this 6. So 6 faces are there. And this total area of this 6 faces is called total surface area of a cuboid. And the formula to find out total surface area of a cuboid is this. So total surface area of a cuboid is 2 times of L is length, B is breadth. So length into breadth plus breadth into height plus height into length. And now formula number 2, lateral surface area of a cuboid. So in this cuboid, lateral surface means this face and this face and this face and this face. These 4 faces are called lateral surface area. And the formula to find out this lateral surface area is this: 2 times heights, and in the bracket length plus breadth. And these 2 are the formula of cuboid. And this lateral surface area of a cuboid is same as area of 4 walls. Now next is cube, and this is shape of a cube. In cube, this length, breadth, height are equal. So all are length. So formula number 3, total surface area of a cube is 6 times L square. Number 4, lateral surface area of a cube is 4 times of L square. Next is cylinder. Formula number 5, total surface area of a cylinder is 2 pi r in the bracket r plus height. This is the formula to find out total surface area of a cylinder. Formula number 6, lateral surface area of a cylinder. Lateral surface area of a cylinder and curved surface area of a cylinder are same. So lateral surface area of a cylinder or curved surface area of a cylinder is 2 pi r height. We need to by heart these formulas. After learning this formula, we are going to solve next exercise 11.3. So for today, let's stop here. Okay, all of you, thank you.